Hi everyone. So this is a tale of learning about how we went with Docker from knowing absolutely nothing about Docker to actually deploying Dockerized applications in production. Yeah. So just to give you a bit of context, work at Elevate with Mick here, and Elevate is a small startup in the recruiting area. I won't get too much into the details of what we do. I will talk more about the technical details of how we're deploying stuff with Docker. But more than anything, this is a tale of learning how we actually learned throughout the months about Docker till we actually got it to production. And it wasn't a very long road, actually. It wasn't that hard as it seemed at first. So how many people here are actually using deploying Dockerized applications in production? Oh, quite a few. All right. So those of you will probably not find this talk very interesting in its technical details, but you might still find it interesting how we got there. Yeah. And oh, sorry, I actually hit the button. You might find it interesting how we've learned, this process of learning how Docker works and eventually getting to production. Yeah. And for those of you who are not using Docker in production yet, it just seems sometimes like the Docker ecosystem is huge and just there's no end to it. And it just seems like you have to know absolutely everything there is to know about it to get to production. And the thing is, that's not the case at all. Yeah, you don't need to know a lot of stuff. And we'll see how, with a bit of low-tech solutions maybe sometimes and a bit of even manual work, you can get to Docker with Docker in production. Yeah. So we got started with Docker, like everyone here probably, by consuming ready-made images. I mean, it's great that you have Docker Hub with lots of high-quality images like MySQL, RabbitMQ, Redis, Mongo. These are the ones that we are personally using. Of course, there's tons more. And the thing about using these ready-made images is that they're high quality, they're well documented, and just by using these images, it will save you a whole bunch of time not having to install these things in your development environment. Yeah. So, for example, if you deploy Elasticsearch with Docker, you don't have to care whether it uses Java 7 or 8 or whatever it uses. You don't have to care about any dependencies. That's the great thing about Docker. Yeah. And so that's a very easy way to get started with Docker. And it's great also because you get to learn the basic concepts of Docker. Yeah, I remember at some point when I first got started with Docker, I didn't even know what the difference between containers and images was. I mean, something as basic as that, I mean, for all of you, it's probably fundamental, but at some point you did have to learn about this. Yeah. You learn about volumes, learn about mapping ports, and the command line interface, of course. I mean, with all the commands, and just running these ready-made images is great for learning the basic concepts. And the important thing is that everything else is built on top of these basic concepts. So it's a must to learn this. Yeah? So of course, after you've mastered or after you're familiar with running ready-made images from Docker Hub, you want to Dockerize your own applications. And of course, you have been peeking into the Docker files for all of these base images, yeah, as an inspiration for your own. Yeah, obviously the first step is to write your own Docker file. But when you actually sit down to write your own Docker file, a lot of questions pop up. Yeah, what kind of stuff do I include in this Docker image? How do you use the Docker build cache? Yeah, you've probably read about it, and you wonder whether you should care about it, or how do you use it to get the best performance out of your builds. Yeah. So my first recommendation here is that when you first get started writing Docker files, you shouldn't worry too much about what to include. I mean, you can just pretty much dump everything in the image, and you can always come back later and prune what you're not actually using. Yeah, but this is not something that you should worry about at first. Yeah, just include everything. Yeah. And about the cache, yeah, that's also an optimization. So at first, don't worry about it all. Just get it built, and then you can always come back later and optimize that. Yeah. Ultimately, it's just an optimization, and you will probably get back to this because once you get the whole process running, you'll want to build your images as fast as possible. But at first, don't worry about that at all. Yeah, just dump your stuff on the Docker file, get it running, then you'll deal with the details. Yeah. But there's a couple of recommendations for your first Docker file, and one of them is always use tagged-based images. I think that's pretty important because obviously that gets you reproducible builds. Yeah, that's a good thing to have. I mean, regardless of whether you're using Docker or not, reproducible builds is a good idea, pretty much anywhere. Yeah, and of course, always try to use official images whenever possible because they're high quality, they're very well maintained, they have lots of contributors, so it just makes sense to use official images whenever possible. Yeah? But at the same time, once you're familiar with writing Docker files, don't be afraid to go off this path of official images, and don't be afraid to write your own base images. Yeah, for your own stuff. But at first, just use official images. I mean, there's official images for Python, Java, I mean, pretty much any platform, any language you're using, except for .NET, of course. I mean, anyone actually has .NET code? Yes. Yeah? Oh, yeah. You're using Mono, aren't you? Yeah. Well, if you're adventurous, you can try Mono, but otherwise, for the rest of us, we're kind of stuck with waiting for the core CLR release. It's kind of a digression for .NET programmers. Yeah. So once you have your Docker file, yeah, you can actually do Docker build in your Docker file and build something. Yeah. Then you'll want to have a proper build process. Yeah, which is much more than just Docker build. Yeah, so you probably already have a build process for your existing applications. You just need to tweak it to have it output a Docker image instead of whatever you're generating at the moment. I mean, at the moment your output might be, say, a jar file, or something like that. I mean, instead of building that, you're generating a Docker image. Yeah. So what that means is first you build the image, but then you have a whole bunch of other things like, well, linting if your language needs some linting, like Python, for example. Running tests, this is pretty obvious and pretty important as well, including unit tests and integration tests. And well, the last step is tagging your Docker image, just as you would tag, say, a jar file or something, or whatever output you have in your current build process with the final version, you know. So it's very important to tag all your images, yeah, and keep track of all the versioning. In particular, for example, for tags, we're using the build number and then the git SHA-1, yeah, so the actual commit. So that gives you a pretty good tag that you can use to trace back to whatever code was used to build the image, yeah. Then, of course, just some cleanup, yeah. We'll see how this is important later. But note how, so far, I've only talked about build process, and I haven't even mentioned any technologies like GitHub or Jenkins or TeamCity or anything. It's because this build process I'm talking about I think it needs to be, first and foremost, independent of all these tools. Yeah? It needs to be something that anyone can run on any machine. Yeah? Which, if you manage to do this, that means that your build process will be portable across build servers, machines, or whatever. I think that's a really nice property to have. Yeah? And of course, once you have all these steps working, you start thinking about how you can improve the dependencies of all these processes. So one, of course, you want to Dockerize these steps. Yeah? You want to Dockerize the compilation of your project. For example, if you have a Java project, there's a Maven image you can use, and I just say Docker run Maven pointed to your source code through a what's it called? A volume, a host volume mount. Yeah, and that will pull all the dependencies it needs to build your project, and you don't even need to have Java installed on your build machine. All you need is Docker. Yeah, you don't even have to care about Java versions or anything. I mean, you say Docker build Maven, you define the Maven version, of course, because once again, always work with tagged images, and it will just build everything for you. Yeah? Unit tests can be Dockerized as well, and it's very nice to have these Dockerized because it's very easy to do it as well. All you have to do, pretty much, is to include your tests inside your image. Yeah? Remember how I just said that you just throw everything in the image, yeah? Including your tests. And then you can just override the entry point for defining the Docker file. And instead of just running your application, just run your unit tests. Really easy to do, and it's great because this actually you actually make sure that you're testing exactly what you're going to deploy later. Yeah? You're actually testing the exact image you're going to deploy later. Which is pretty cool. Integration tests, also great for Docker, because once again, you can just override the entry point for the image and define through environment variables or linked containers whatever external sources you're using in your integration tests. Yeah. Say, for example, you can even create a transient, I don't know, MongoDB container. Just link it to the container that runs your integration tests. Run your integration tests against that transient Mongo container, and then get rid of that container altogether. Really easy to set up. I mean, it's just literally a couple of lines of shell script. And yeah, again, this way you make sure that you're testing against the actual code being deployed. And well, linting for those languages that need linting, such as Python. Yeah, it's really easy to do. It's just like pretty much like compilation. Yeah. So once you have this build process in place, yeah. Again, I haven't even mentioned any tools like GitHub or Jenkins or anything else. Yeah. But once you do have everything in place, and you can run it on any machine, you'll want to automate it, of course. And of course, being a Docker newbie, you might Google for Docker continuous integration or Docker build server or something like that, and you'll find a whole bunch of solutions like Drone.io, Shipple, Circle CI that are pretty specific for Docker-based solutions. And yeah, to be honest, they might be great, but at this point, when you're just getting started with Docker and you've just written your first build process for Docker, you're probably not fit to evaluate these solutions. So I think you would only just waste a lot of time that you could be using for other things. And you probably even already have build server installed in your infrastructure. And you probably already have either Jenkins or TeamCity or something similar. So why not just use what you already have? I mean, it just makes sense. Why not? Yeah, don't waste time trying to evaluate these solutions when you can already use this. And the good thing is that because you've written all your build scripts in a very portable way, you can just use this. Yeah. It's very easy to implement this. So this is the actual workflow that we're using, and it's the one that's described in this PDF down here from Dockerfile. I'll describe it to you because it's probably not very readable, but it's really simple. So basically, the workflow starts with the developer pushing to GitHub. Yeah. Then there's a Jenkins instance pulling those changes either through a GitHub webhook or just by polling the repository, basically. And then Jenkins launches what I described a few slides ago, basically the build process, which starts with a Docker build. Yeah. So first of all, you build your image, and then you test the image. And the last step, which I haven't mentioned yet, is pushing that tested image to a Docker registry. Yeah. So this Docker registry, it could be, for a start, it could be Docker Hub, could be, there's another one called Quay.io, something. But I think ultimately you'll want to deploy your own registry in your own infrastructure. Yeah. I think it makes sense because it's really easy to do so. And not just that, it has benefits like not having to mess around with access keys and authentication for Docker Hub. And plus, by having the registry on your own infrastructure, say for example you're running the whole thing on AWS, on EC2, then network transfers are really fast, which makes deployments and builds really fast as well. You know how Docker images can get quite big, and this really makes a pretty big difference in terms of the performance of building the images and deploying stuff. Plus, it's really easy to set up a registry nowadays. Of course, deploying a registry is a Docker container in itself. It's actually 3 containers. I think it's the actual registry, a Redis cache, and the UI. But you can just put these 3 containers in a Docker Compose file, for example, and launch the 3 together. You can use S3 if you're on AWS. You can use S3 as a storage backend, so you don't have to worry ever about where you're actually storing these images. It just works. It needs no maintenance at all. Really easy. Definitely recommended. All right, so once again, once you're starting to build this workflow, right? You'll wonder how you're actually, integrating Jenkins with your build process. Yeah. So you'll probably start searching around for Jenkins Docker plugins or something to make your job easier, right? And you'll find some things like this, for example, which is a Docker plugin for Jenkins. That, well, for some reason, this screenshot is in French, but don't know why. But you can probably figure out what it's about. Basically, it allows you to run your build process inside a Docker container. Yeah, and you define here what image you will use to run your build process. Yeah, in this case, for example, it's using Maven 3.3.3 or something, and then you define here what Maven targets you will use to build your stuff. But the thing you need to realize about this is that you're essentially programming your build process in a visual way, yeah, instead of actually having it in a simple script version right along with the rest of your source code. So not only do you lose that property of having your build process version right with your source code, but you're also not buying too much with this. Yeah, so it's just literally this is just 5 lines of shell script. It doesn't buy you anything. Yeah, so absolutely avoid. I would recommend to avoid all these plugins. I mean, not only are they not worth it, they're just, I think they're actually harmful. Just avoid them altogether. Yeah, it's nothing that you couldn't write in 5 lines of shell script. Yeah. All right. So once you get your build process or automated, builds your images, deploys to pushes the images to your registry. Of course, then there's the other part of actually grabbing that image from the registry and actually running it on your target environment. Yeah, this target environment could be your development environment or your production environment or something in between. Personally, we're having 3 environments at the moment. We have develop, which is being continuously deployed from builds. We have staging, which is used for demos, so it's kind of a more stable environment. And then, of course, production, yeah? So you'll have a bunch of questions when you start thinking about deploying things, yeah? Obviously, what kind of platform, what kind of operating system will I use to deploy these Docker images, yeah? The Docker containers? What's the process I will use to actually getting these images to run in this target environment? Things like load balancing. I mean, obviously, you probably want to deploy to a cluster instead of a single host. So you'll be thinking about how to do load balancing and how to automate that, for example. Yeah. So again, as a newbie, the thing is, you start, oh, what kind of platform do you use? Oh, just Google it, yeah? See, and you'll find a whole bunch of platforms, yeah? Some of them you can download and run on your own machines, for example. Some of them maybe not. And some of them you have to pay for them. And of course, they all promise great features. And they promise to be really simple to use, and whatever. But the thing is, again, at this point, and not having done any deployments at all yourself, you're not in a good position to evaluate these. So instead of going with any of these that promise to, save your life, basically, yeah, and so you just click and run, yeah, great. But there's bound to be many details behind that. Instead of doing that, why not just just use your current infrastructure? Say, if you're using AWS, just launch a bunch of, EC2 instances, install Docker on them. The one thing you need to keep in mind is that, Docker, by default, the Docker daemon only listens by default on the local socks, local socket. So obviously, if you want to deploy things automatically, you want to configure it to listen on TCP, for example. But really, I mean, I think for your first deployments, I would advise to stay clear of all these solutions and just, again, use what you know, yeah, and that just might be enough for your use cases, or might be not, but then again, it might be just enough, yeah. And of course, if you choose to deploy on your own platform, yeah, just, of course, you still have to pick an operating system, which could be just standard Ubuntu plus Docker. There's a new distribution called Snappy Ubuntu Core, which is, I haven't tried it myself, but it's supposed to be more friendly for Docker containers. I don't know. Has anyone tried it? No? Anyone even heard about it? Yeah, have you? Yeah. So yeah, it's a relatively new one. And then of course there's CoreOS and DCOS, which actually are more geared towards clustered management. So, and they have a whole bunch of useful features. But again, for your first deployments, you probably wouldn't know what to do with them. So I'd say, and there's Rancher OS, which is kind of a middle ground between standard Ubuntu and these fully fledged clustered dedicated operating systems. It's kind of, I think it's kind of similar to Snappy Ubuntu Core. But my recommendation is for your first deployments, just go with standard Ubuntu. You can't go wrong with it. Just install Docker in it. And it's really easy to provision because all you need is Docker itself. It's literally just maybe 10 lines of shell script. I mean, you probably don't even need something like Chef or something. You could, of course, if you already have a Chef infrastructure. But yeah, just go with what you know. Yeah, it's probably enough for a basic deployment. Yeah. And this is how the actual deployment process works for us, at least. It's pretty simple overall. It starts with a Docker swarm being set up by the deployment script. Yeah. There's a Docker swarm that points to the target cluster. This target cluster, again, could be your development environment, staging, or production. And the only thing you need to change in this process is what target nodes, are you deploying to. So it could be, and this is just an environment variable being passed by Jenkins itself. Yeah? And Swarm, of course, you can run through Docker. So it's really easy to set up. It's just literally setting up this Docker swarm is 2 lines of code. Yeah? It's 1 line for this and 1 line to stop it. That's pretty much it. And the nice thing about deploying through Docker Swarm is that then you can just talk to Docker Swarm and it will in turn talk to the Docker cluster. Yeah, but you're only dealing with what seems to be a single instance, a single Docker host. Yeah. So that simplifies things a bit in this deployment process. So once you have your Docker Swarm set up, all you have to say is Docker run, registry image, pass the environment variables, for example, connection strings or whatever you need to actually run your Dockerized application. And then, these Docker clusters will fetch the actual image from your Docker registry and run them. And that's pretty much it. I mean, don't need much more than that. And this whole process, even though it seems simple, it might look a bit complex, but it's actually just 50 lines of shell script. And it's really easy, it's really simple. And well, once you have everything deploying all nicely, you commit stuff to GitHub, and it automatically builds your code all Dockerized and generates a Docker image and deploys it automatically maybe to your development environment. You start looking for ways to Dockerize more and more things. Yeah. So for example, you might start thinking about how to Dockerize your build server. And in our case, we're running Jenkins as a Docker container. And it's not just a matter of saying Docker run Jenkins, whatever, but it also means that you can use that official Jenkins image as a base image for your own Jenkins instance with whatever plugins you need to set up. Yeah. And this makes it really easy to keep your own Docker file under version control with that just installs whatever plugins you're using. Yeah. Anyone actually using Jenkins here? No? Not many. Oh, that's kind of surprising. Yeah. Thought it was more popular. Yeah. And yeah, this is a great win because you actually versioning your build server configuration. Yeah. If it goes down at some point, you can just Docker run it and somewhere else, and that's it. And of course, you'll want to map your config to a Docker volume. So if you ever upgrade your Jenkins version or you add a new plugin, you won't lose your configuration. Yeah. And yeah, after that, you start looking for more things to Dockerize, like logging and monitoring. Yeah. So in the case of logging, you might want to start looking into logging through Logstash or Fluentd. For example, so if you're Dockerizing an already existing application, you're probably logging directly to your actual logging storage, like Elasticsearch or something. But instead of doing that, you might centralize all logging through Logstash or Fluentd. And you might want to Dockerize monitoring. Yeah? For example, in our case, we're starting using Reman, which is pretty cool because it lets you configure all your monitoring as a Clojure file. Yeah? So it's basically it's configured through Clojure, and that Clojure is run embedded inside the Reman server. And it's really easy to Dockerize that, and it's really easy to deploy that once it's Dockerized. Yeah? More recently, we've switched to Datadog. Anyone using Datadog here? Yeah? Only one? Two, three. So Datadog also has good support for Docker, in that you can deploy the agent that grabs all the stats for each host. You can deploy that agent through Docker. And this all means that you can use roughly the same build process and the same deployment process for your own applications as for your monitoring Docker container. Yeah, it's pretty cool. It really simplifies things. So that's all nice and good, but of course, it's a whole bunch of difficulties with this approach. One of them is we're currently having to manage ports manually. What does it mean? It means that for each application that is deployed, we have to keep track of what port it will expose, yeah, on the actual host. Because otherwise, if we don't do that, we'd get port overlapping, and that's obviously not an option. Yeah. So we have to keep that in mind ourselves instead of it being automated. Our build scripts are kind of growing a bit more than we're comfortable with. I mean, I did say that it's just 50 lines of shell script, but 50 lines of shell script is 40 lines too many. Yeah. I don't want to program in shell script at all. It's not a language you want to program in. I think ideally you just have single liners, just calling something else maybe, but I just don't want to program in shell script at all. It's not a good language. Yeah, I have some pretty strong opinions about languages, but then again, who doesn't? Yeah. So, and related to that, we have duplicated build scripts. I mean, which means that we have 4 or 5 projects that are using pretty much the same build scripts, and these build scripts are, duplicated in all these repos for all of our projects. Obviously, that's not good. We might want to we want to abstract a library, for example, but I'm not going to build a library out of shell scripts, just because again, I don't want to write more shell script at all. I don't want to write bash. Yeah. So that's one problem. And of course, managing dead or all containers and images is a problem. For example, I found out the hard way that if you just, in your build process, if you don't clean up the images you're building after pushing them to the registry, they will stick there in your host and eventually fill up your hard drive. Yeah, so I found that the hard way. And either you just clean up after pushing your images to the registry, or you have a some sort of cron job or something that could be also Dockerized, why not? To clean up those images, yeah. And service discovery and load balancers. I mean, I did mention load balancers, but we're not dealing with this automatically. I mean, we don't have this automated at the moment. We're managing this manually, and it's not a huge deal for us because we don't have a huge cluster and we don't have a huge number of services. But as our number of services is growing, this is becoming more and more of a problem. Yeah. But the main point here is that you probably shouldn't aim to automate absolutely everything in your first few deployments with Docker. You might have to automate things later down the road, but then again, maybe you don't need that if you have a small enough infrastructure. Yeah, it's not a huge deal. I mean, you read all these blog posts and articles that just say, oh, just do this and it will automate this, and you don't have to configure this. And it all sounds great, but you might not even need that, and it just might be far more complexity than you can handle, maybe. Yeah. So all these difficulties then end up on us just deciding to adopt Kubernetes. Yeah, and we've just now started using Kubernetes. We have yet to deploy something in Kubernetes, but Matt from JustStack here has been helping us quite a bit with this. I think Kubernetes is one of the main things that Kubernetes brings to the table is new abstractions. I think this is one of the most important things. Pods, services, and namespaces. I think you'll have a talk about Kubernetes more in detail later, won't you? Yeah. So I won't talk too much about Kubernetes because we've just started using it. But by having abstractions to deal with these things, with these difficulties I just mentioned, I think it will just make things much easier in terms of simplifying things. Yeah, it will just simplify a whole lot of things. And well, Kubernetes, for example, has first-class support for load balancing, and you don't have to worry as much about the low-level details of networking and stuff like that. Yeah. So yeah, basically, I mean, we're not hoping that Kubernetes will solve all of our issues, but I think it will certainly simplify things. But the main thing is, even with all these difficulties, this low-tech solution, if you will, that we've adopted has been working great for us for the last few months. We've been able to deploy containers in production for the last few months with not a lot of issues. Yeah. So it might be the case that this kind of low-tech approach is useful for you as well. And eventually maybe you'll upgrade to Kubernetes or something that manages a cluster, but you know, more in a more direct way. But other than that, I think a low-tech solution might be useful for learning and to get started. Yeah. All right, so that's it. Any questions?